Okay, so in this video, we're going to be talking about the process of FOILing, and in particular, extending that process beyond multiplying two binomials together. So let's recall what FOILing is. So we use FOILing when we are multiplying two binomials, and the terms stand for first, outer, inner, last. That's what the FOIL stands for. Okay, sorry about that interruption. I don't know what I hit, but we got interrupted. But continuing, FOIL stands for first, outer, inner, last. So the idea here is that you're going to take the first component of the first binomial and you're going to multiply it by the first component of the second binomial. And then that's what the first stands for, first and first. And then you're going to take the first component of the first binomial and multiply it by the last component of the second binomial. So that's outer. And then inner, you're going to take the second component of the first binomial and multiply it by the first component of the second binomial. So that's our I. And then the second component of the first binomial times the last component, the second component of the second binomial, that's the two last terms. So that is our L. So that's what FOIL stands for. Now, you'll notice that essentially what is going on here is you are taking the first component of this first term and you're multiplying it by every term in the second product. And then you're doing the same thing with the second term. You're going to multiply that one by everything in the second factor. And if you had more terms, you would continue doing that process. This one, the first one by every term here, the second one by every term here. If you had a third one, the third one by every term over there, and so forth. So that's the general extension that we're going to be looking at. So just as a reminder, we'll do an example with the binomial, and then we'll extend this to a binomial with a trinomial and a trinomial with a trinomial and so forth. So here we're going to look at our first x times x, so the first component times the first component. So that's going to get our x squared. And then x is going to multiply -2, so -2x. We've now multiplied x by everything in our second term. And so now we're going to go on and we're going to multiply the 3 by everything in our second parentheses. So now 3x, and then 3 times -2 is -6. And then we can combine whatever like terms we have. And that is our multiplied out problem. So now let's consider x plus 2 times x squared minus 2x plus 1. So now we're going to multiply out a binomial with a trinomial. So the idea here again is we're going to take that x and we're going to multiply x by everything in the second parentheses. So x times x squared is x cubed. X times 2x is -2x squared. X times 1 is x. And then we're going to move on and we're going to multiply 2 by everything in the second parentheses. So 2x squared. And then 2 times -2x is -4x. And then 2 times 1 is 2. And then we're going to add up all the like terms. So x cubed is only the one thing. We have a -2x and a +2x, so those cancel. We have an x and a -4x, so that's -3x, and then plus 2. And so that will be our final example, our final version of the multiplied out process. If you have multiple factors, you would just do this 2 at a time. If you had 3 linear factors, let's say x plus 3, x minus 2, and x plus 1, you would multiply two of your binomials together. You would get a trinomial out of those, and then you would multiply your trinomial by the remaining binomial as we did here. And so let's just do one additional example. We'll throw in some more interesting powers. We'll do two trinomials. And again, the idea here is to be methodical so that you don't miss anything. So I'm going to take x to the fourth and I'm going to multiply it by everything in the second parentheses. X to the fourth times x squared is x to the sixth because I add exponents. X to the fourth times 5x is 5x to the fifth. X to the fourth times 7 is 7x to the fourth. And then I move on to my x squared. X squared times x squared is x to the fourth. X squared times 5x is 5x cubed. X squared times minus 7 is 7x squared. And then I move on to the 3x and I multiply the 3x. 3x cubed. And then I multiply 3x by 5x and I get 15x squared. And then I multiply 3x by negative 7 and I get negative 21x. And now I have to combine my like terms. There's only one x to the sixth. There's only one x to the fifth. I have an x to the fourth and an x to the fourth right here. So that'll become negative 6x to the fourth. I have a cube and a cube. So that'll become positive 8x cubed. I have a negative 7x squared and a 15x squared. So that'll become 8x squared. And then I have a 21x. So again, the idea here, simply try to be methodical. You will sometimes see, especially when you're first learning how to do this, you will sometimes see this written out as x to the fourth, and then the product, your second parentheses, like so, and then x squared times the second parentheses, and then 3x times the second parentheses. Again, the idea here is you're multiplying each of the components in your first parentheses by the entire second parentheses, and then you're just doing the distributive rule, distributing through each of the parentheses, and you'll see that when you actually do this, you will get exactly what we did here. Now, when you get some practice with it, they don't really write this out anymore. We just go straight to the sort of mental repeated foiling. We sometimes don't refer to it as foiling, even though first, outer, inner, last doesn't really apply anymore. But it's this process of distributing parentheses through parentheses.